Okay, to show that quadratic, like x squared plus bx plus c, so anything in that form is always positive for all x values. There's actually a couple of different methods of doing this, but if you are using the discriminant, then what you need to do is look at what type of roots that you would have if this was to happen. So if you sketch your quadratic and it was somewhere above the x-axis, then all the values of x, no matter what values of x you have, and you put those in there, the y values will always be positive. So because the y values equal ax squared plus bx plus c, so once you put the x in, then you get the y value. So that means that this whole expression, when you put the x in, it will always be positive. Okay, so that's because the y values, when you put the x in, are positive. So if it is always a positive expression, so if that is always above the x-axis and always a positive expression, then the types of roots would be unreal. Because if you look at that, it does not cut the x-axis whatsoever. So it doesn't cut the x-axis, so therefore it has no real roots. Now, for an expression to have no real roots, the discriminant would have to be less than 0. Because that means that when you solve your quadratic equation, what's underneath the square root, because you've got actually minus the square root, this is this, for AC, the discriminant is what's underneath the square root, and what's underneath the square root would have to be negative. So that's that there, that's your discriminant. So the other thing too, for it to be above the x-axis, it needs to be facing upwards. So therefore it has to also be a smiley face parabola. So it has to be smiley. So the condition for an expression to always have positive values of x, the condition for this to happen would be the discriminant would have to be less than 0 because it has no roots. And the a, the thing in front of the x squared, would have to be positive. So that means that the parabola, resulting parabola, would have to look like that. So let's look at an example on this now. We'll just look at an example for the positive one. Okay. So you just want to show that x squared minus 4x plus 9 equals 0 x squared is always greater than 0. That's basically what we're going to do. We're going to show that that is always greater than 0 for all values of x. Okay. All right, so first of all, the a is the number that is in front of the x, so that's a 1. The b is the number in front of the x squared is the a. In front of the x is minus 4, that should be. And the number on its own, the 9, that would be the c. So the discriminant is equal to b squared minus 4ac. Now, for it to always be greater than 0, the discriminant would have to be less than 0, because then this would be a parabola that has no roots, and the a would have to be positive. So already, if you look at this, the a is greater than 0, so that box is ticked. What about the discriminant? Okay, so let's look at the sign of the discriminant. So b is minus 4, so sub the b in. A is equal to 1, so sub the 1 in, and c is equal to 9. Minus 4 squared is 16. 4 times 9 is 36. 16 minus 36 is minus 20. That is negative, so therefore it has no real roots. So because both of those things are met, the discriminant is less than 0 and a is greater than 0 or positive. So therefore, that expression x squared minus 4x plus 9 is greater than 0 for all values of x. Now, I do have another way out that is this is a quick way that I believe you could also use. Okay, you could actually do a really quick sketch of that parabola by looking at the first two numbers there and completing the square. So you halve the 4, then you get 2, then you square it, then you get 4. So you add 4. Now, that is nearly the same equation as the one I have above, except it's not 4, it is 9. So what you need to do is go, okay, 4 plus what? 4 plus what will give you the 9? Okay, because it has to be equivalent. So 4 plus 5 will give you the 9 is greater than 0. So all I've managed to do is take that 9 and divide it into 4 plus 5. The x squared minus 4x plus 4x can then become x minus 2 all squared, because I've completed the square, plus 5, which is greater than 0. So if you now went to sketch this, then it would be 2 to the right and 5 up. So it looks like that, and it is a happy face parabola, so it looks like that. So if you just drew a picture of it and you say, therefore, the parabola is always above the x-axis, so therefore that means that the parabola, which is this expression, would always be greater than 0, because the y value is greater than 0, therefore that expression would be greater than 0.